morning. Suppose we have a circuit like this and we want to calculate the current flowing in the branches. We're going to use two methods, Kirchhoff's law, and we will try to introduce superposition method, which states that a circuit, we can divide it in many circuits depending on the sources. Here we have two sources, we can divide it in two circuits and we can calculate the currents and later add these currents to find the total currents. Here, for example, we can divide it in two circuits. First circuit is V1 on its own, working on its own. Here we have first circuit without V2, and the second is V2 on its own. So it means we have to calculate if we can call this one I1, this we call it I3, and this we call it I2. So it means here I1 prime, this one is I1 2 prime, here we will have I3 prime, I2 prime, and here I2 2 prime, or second I3 2 prime. So it means that the total current here will be I1 prime plus I2 I1 2 prime. I2 will be equal to I2 prime plus I2 2 prime, and I3 will be equal to I3 prime plus I3 2 prime. So let's first use this circuit to calculate the currents, and then we can use the equations that we derived here to calculate these two currents. Okay, so the first thing to do is to choose direction of currents. If we have chosen this direction of currents, remember that the drop here will be in this direction because the current flows from higher potential to the lowest. VR2 is in this direction because the current flows from positive to negative. Same thing here. We will draw VR3 is in this direction because the current flows from plus to minus. And then we can choose a direction of writing these equations. We choose direction of clockwise. This is loop 1, loop 2, and this node here. So we can write three equations. First equation here, sum of voltages should be 0. Second loop will write sum, the algebraic sum of the voltages is 0, and here we will write sum, the algebraic sum of currents are 0. So it means the currents entering a node should be equal to the sum of the current leaving the node. So if we go in direction of clockwise direction, if we come from minus to plus, we write plus V1. If we go from plus to minus, we write minus VR1 minus VR2 is equal to 0. This is first equation. Second equation is if we go from minus to plus, I said that we can write plus minus VR3 and minus V2 is equal to 0. And another equation is the equation in the node. The sum of the currents entering a node is equal to the sum of the currents leaving the node. So it means I1 should be equal to I2 plus I3. From here, using the Ohm's law, we can write that V1 is equal to R1 I1 plus R2 I2. So it means we rewrite first equation this way, and V2 should be equal to R2 I2 minus R3 I3, which is VR3 and V2. We have a system of equations, but we have two unknowns. We have to replace one of them. For example, if you take I3, replace it with I1 minus I2, we will get something like this. I1 minus I2. Rewriting this equation, we will have V1 equals R1 I1 plus R2 I2, and V2 is equal to minus R3 I1 and R2 plus R3 plus R3 times I2. Now, numerically, we can write, coming back to these equations, we can write, we introduce numerical values. We have 10 volts is equal to 4I1 plus 8I2, and 4 is equal to minus 6I1 plus 14I2. And now we'll try to solve these equations, multiplying by 6 here and 4 here. We can calculate I2. So 6 times 10, 60, 24I1, and 6 times 8, 48 I2. Here we will have 16 is equal to minus 24 I1, and here is 56 I2. If we add this together, we have 60, 76 is equal to 0, and here we will have 104 I2. From here we can calculate I2. I2 is 76, or we can say 60 plus 16 over 104. It means it's equal to 0.7307. So it means this current I2, I will write it here, is equal to 0.7307 amps. From here we can introduce it to one of these equations. This means that 4I1 is equal to 10 minus 8I2 over 4. So I1 is equal to 10 minus 8, 0.7307, which we have calculated, and it's equal to 1.0383 amps. Writing I1 here is 1.0383 amps. Okay, we have calculated I2. Now we can calculate, I will leave this equation because it might help later. 60 plus 16 over 104. Okay, now we can calculate I3. I3 is equal to I1 minus I2, and is equal to 1.0383 minus 0.7307, and it's equal to 0.0308, about 0.308 amps. Okay, now we can go to the next circuit. So we'll try now to go next circuit to calculate I1 prime. So what is the difference between this and this? It means that V2 is equal to 0, so it means we change this one to 0, this one to 0, so we'll have 60 plus 0, this is, so I2 prime, so now we are calculating I2 prime. I hope I haven't forgotten any of this. So here we calculate this one, and this one is equal to 0.577 amps. And I2 prime, we can write I2 prime here is equal to 0.577 amps, and I1 prime is equal to 10 minus 8 times 0.577 over 4, and this one is equal to 1.346 amp. I1 prime is equal to 1.346 amp, and we can calculate I3 prime is equal to I1 prime minus I2 prime, and is equal to 1.346 minus 0.577, and is equal to 0.769. I3 prime is equal to 0.769 amps. Well, I didn't use a point, I used comma. Okay, this is a point. I confused it with the French method. Now we can go to calculate I2 second. So it means they are the same equations. Now V1 is 0. Here will be 16. Here will be 0. Here will be now 16. This is I2 prime. I2 prime will be 60 over, so now it's 16, 0 plus 16, and it will be 154 amps. I2 second is equal 154. I1 second, I will calculate it now. This is 0 minus 8, 0.154, and this current will be negative. It will be minus 0.308 amp. Let's write it here, minus 0.308 amp. Left I3 2 prime is equal to I1 2 prime minus I2 2 prime. It's minus 0.308 minus 0.154, and I3 2 prime is equal minus 0.462 amp. Now I3 2 prime is equal to minus 0.462 for 62 amp. Let's see whether we did calculations are correct. We have to verify our I2 is equal to I2 prime plus I2 second. I1 is equal to I1 prime plus I1 second, and I3 is equal to I3 prime plus I3 to second. Let's see whether we did good calculations. 0.577 plus 0.154, and this is 0.73 amps, I think. I1 prime is equal to 1346 plus 0.1 minus 0.308, and the result is 1038 amps, and I3 is equal to 0.7663 minus 0.462, and this is 0.308 amps. As we see, the result is the same as the result we have here. So this is superposition, so it means the current I1 is equal to I prime plus I2 is equal to I2 prime plus I2 second. I1 is equal to I1 prime plus I1 second, and I3 is equal to I3 prime plus I3 second. And this is what we call superposition method. And thank you for your attention.